We are talking about naming. And we have two types of compounds, molecular compounds and ionic compounds. So we are going to have a little bit different set of rules in naming both those types of compounds. So, and it's important. I mean, everyone needs to describe the same compound the same way, no matter where you live in the world. So it's an important thing to do. And so one of the things we're going to have to do today is figure out whether something is a molecular compound or ionic compound. So then we know what set of rules to follow, right? So let's get started. So let's start, though, with just single atom ions. How do we name them? Now, first off, though, Emily, what's an ion? What's an ion? Ion. Like, let's back up. What's an give me a name of an atom. Give me a name of an atom. Yeah, any atom. Hydrogen. Okay. So there's an atom. Now remember, these atoms all have a nucleus and they have neutrons and protons in there. But to make the ions, you're either adding what or removing what from that atom? Electrons, right? You add electrons, the thing becomes negative or positive. Yeah, if you somehow this thing grabs onto more electrons, it's going to get negative because now it has too many, right? Loses electrons, somehow becomes more positive. Okay, those are ions, right? Not an ion, you'd call that an atom, I guess, right? There's an atom. Now hydrogen likes to form this, H+. Okay, so that's what an ion is. You're just adding or removing electrons to the neutral atom. Okay. Now, for us to name these, it really, really helps to identify the metals and the nonmetals on this periodic table. Because there's our periodic table. There's all of our atoms. Just identify the metals and the nonmetals. So if I wanted to circle all the metals, let's make them dark or something. Would I circle a small portion, do you think, of this table, Bowdy, or a huge portion of this table? In nature, most everything is a metal, or is it a nonmetal? Does anybody know? In nature, most everything is a metal. I'm going to circle almost this entire periodic table. I'm going to all the way up until that little squiggly line there, kind of. All metals. Okay. So, yeah, hydrogen is argued. It has a metallic character to it, so let's just throw it in there. Okay. And they're all going to form positive ions. So that's why it's nice to identify all the metals, all the nonmetals, everything else. Right? Form negative ions. Right? Nonmetals. They'll form negative ions. So that right there is going to help us out a lot. Okay, so when it comes to ions, Ashley, metals always form positively charged ions. Okay, but what do we call them? Cations. And then nonmetals always form negatively charged ions called, everybody? Anions. Yeah. Okay, so just remember the metals versus the nonmetals. That's really going to help us out here. So let's start out with the metals. Right? How do you name these atomic metals? All these cations. Okay. So we named some of these. Remember we said, oh, we called this the alkaline earths. We call these the alkalines, right? But what you do is you go by that Roman numeral out in front of the A. So all of those will have a +1 charge. All of those elements in that group. All those elements in 2A will have a +2 charge. So our cheat sheet really is this periodic table. There's your cheat sheet. Okay. So elements of 1A can only have a charge of +1. So how would you write the ion of sodium? You'd write it as Na with a plus. A lot of folks, see, we're already getting lazy on our notation. We technically should write Na +1, but a lot of people are just writing this. And you're going to see that a lot. Fine. Just, right? Just have to get used to it. Na plus. And how do you name it? Sodium. Right? 2A can only have a charge of +2. So magnesium, magnesium. Megan, what was the symbol for magnesium? Mg. So magnesium would be +2 because it's in that group 2. Okay. And how do you name it? Magnesium. So the ion and its atom name are exactly the same thing for groups 1A and 2A. And the reason why they do that is because the charge has no choice. The charge has no choice. Group 1 has to be +1, and group 2 has to be +2. No choice, so the atom name is the same as the ion name, the cation name. Not so for every other single metal. Every other single metal, the group Bs. Notice they have that periodic table doesn't have a B's on them. I climbed up on the ladder and put the A's on those, but I didn't. I should have put the B's on the other ones. So let's have to use this periodic table. And you see the B's. Okay. So these, for our intents and purposes, we're not going to memorize what all the positive charges could be. For us, let's just say they can be anything. Now that's not really how it is. Like copper can only be I've seen +1, +2, and +3. But who cares, right? Just realize that anything with a B in front, it can be a lot of, it has to be positive, but it can be a lot of different possible numbers. So our naming convention for this is to put the charge in parentheses. So if this iron ion is named iron 3, well, that's going to be the symbol with a +3 on it. But what's the symbol for iron? Fe. So how would you name this ion? You just call it iron 3. Okay. Very different than the group A elements, right? You just name the element and you're done because the charge is fixed. So that works for every single cation, right? It all works that way. So group A, just name the element, and you put the charge as the group number. Group B, give the element name, and then say the charge in parentheses, right? Okay. There's only one additional one, and now we're getting into something called, this is what's going to make your life, this is what's going to give you something to study. Whoop, how do you spell polyatomic? Polyatomic. This is our first polyatomic ion. And at least for cations, there's only one of them to worry about. So polyatomic is you just have to know it. It's a nitrogen and 4 hydrogens, and it has a +1 charge. So it exists in nature, and okay, and that's just a polyatomic ion. We just have to know it. Okay. Are we good so far? Now the anions. So now we're talking about the nonmetals. Okay. How do you turn them into ions? And remember that nonmetals have to be negative. Okay. So what we're going to do is we're going to take 8 minus the group number. It always works. And then add "ide" to the name. For example, if you see, I don't like doing math. I'd rather just count. For example, if I see N, I count over 1, 2, 3. Just count over to the nobles. So All these nonmetals don't have any choice. Now, they're all going to be negative. And use the cheat sheet, the periodic table, to figure out what the charge is going to be. I had to count over to the nobles three times. 3 boxes to get over there. So I have a negative 3. Now, you can do 8 minus the group number, 8 minus 5. It just seems easier to count over, right? And then you're not supposed to call it nitrogen anymore. You're supposed to call it nitride. That's where all these ides are coming from, right? For example, let's see, like S. S would have a what charge on it, Kenneth? A negative, and a negative what? Negative 2. Do you see how he did it? He found sulfur, 1, 2, and counted over. And you would call that, Paul? Not sulfur, but sulfide. I'll just do one more to make sure you're following me. Carbon. What's the ion that carbon forms? All right? And what's its charge? What's the ion that carbon forms? Its name? Rebecca, what would you say? What would be the charge on it? On carbon. Carbon. So find carbon. Negative 3? Negative 4. Negative 1, 2, 3, 4. Negative 4. And you'd call it Anybody help her out? Carbide. Carbide. So all these ides, just add the ides to them all. Okay. And we'll do a bunch more of those when we get to naming. So life doesn't seem so bad, right? If this is all it is, right? If you have these cations that are all positive, and we know how to name them now, the anions, and we know that to make these compounds, you need a positive and a negative. They stick together. That's what holds them together. That's an ionic compound. It doesn't seem so bad. But this is what makes life rough, I think, are these polyatomic ions, right? And look at this whole table. We need to know them all. We need to know the names, and you need to know their formulas. Like nitrate is NO3 minus. So we just need to know them all. Now, there are some ways that really help you out. If you use your phone, get the Study Blue app. It's free. And then if you want to use your PC, there's another nice website, Quizlet.com. Or you can make your own flashcards. And when you do this flashcard thing, whether you do it on your phone or on the computer or you make your own, say it out loud. It's going to sound weird, so you might want to go somewhere, but it gets into your brain faster. I don't know how that works, but it does. If you say it out loud, say your answers out loud so that you can hear yourself. Okay? And just get them down. Okay? Our first lab next week will be on naming. And your partners aren't going to be too happy with you if you don't have a good clue on this stuff. So try to get this stuff down by lab. Okay. So how do you name these ionic compounds? Now what is ionic? Ionic is always something positive, some positive ion, and then some negative anion. That's always what these ionic compounds are. Okay. In fact, what I should do here, show you the whole story. Let's say this is a positive, I don't know, let's call it X, and our other guy is a negative Y. And what you do is you have to, like if you touch any compound, you don't get a shock. So that means they have to be electrically neutral. So you have to have just as much plus as you do negative, right? They have to cancel out. So you can do the math or just move these subscripts down. Move the Y down there and the X down there. So that's going to be how we're going to be writing these ionic compounds. But not only do we have to know the the charges of everything, but to write his formula, just do a cross thing on the charges. Make the charges the subscripts. And that's how we're going to write the chemical formulas. For example, calcium chloride. Okay, so we have to write calcium and chloride. And we have to write their ions. So calcium, Alyssa, has what charge? Positive 2. Now again, we can use our cheat sheet. One thing you can do is remember the first guy is always positive. Second guy is always negative. And since it didn't say calcium 2 or calcium 3 or anything like that, you know it has to be in group 1 or 2. So just go over there and look. And she did, and she says, oh, that's in group 2, so she wrote plus 2. Chloride. Mia, what charge does chloride have? So use the cheat sheet. Negative 1. She counted over, only 1 over to the nobles. All right? Only one thing left to do. Move the charges. Right? So a 1 under the calcium, a 2 under the chloride. So you can leave it like this, or you can kind of clean it up and say, oh, CaCl2 is your answer. So, but I don't mind at all having the charges in there and the 1 subscripts. It's all good to me. Okay. So this always works when you have ionic compound. The positive, the negative, you move the charges around. But how do you know? Because look what's coming up next. A different type of compound. How do you know you have an ionic compound in the first place? Ionic compounds always contain a, ooh, good, metal. Way to go, Stephanie. Always contain a metal. If you ever see a metal, this is the game you got to play. And remember where the metals are, pretty much the entire periodic table, right? Pretty much the entire periodic table. You see one of those, it's got to be a metal. And that's the game you have to play. Name the cation, name the anion, move the charges as subscripts diagonally. Okay. Now you see a compound, you don't see a metal. Here's some examples. Sulfur and oxygen, phosphorus and oxygen, hydrogen and oxygen. See, hydrogen is kind of that goofy guy. So don't really think, remember I think Lorena asked, hydrogen's a metal? If you do it, put it in the right conditions, it does. But we're treating it as a non-metal. So you don't see a metal in here. So you don't name cation and then anion. You have to instead count to 10 in Greek. You know how to count to 10 in Greek, and then you can name these compounds. Because we already know S is sulfur, O is oxygen. It would be nice if we didn't have to count to 10 in Greek. We would say 1 sulfur and 2 oxygens. But that's not how they do it, right? They're going to call it monosulfur, and how do you count to 2 in Greek? Someone said di. That's right, it's di. Dioxide. Okay, so let's see if we can count to 10 in Greek. What is 1? Mono. All right, you see it? Mono. What's 2? Di. 3 is tri. 4? Tetra. What's 5? Now it's kind of getting geometric, kind of. Penta. 6. Hexa. Kenneth knows how to count to 10 in Greek, I think. 7 now. Not with an S, but an H. Hepta. Hepta. So mono, di, tri, tetra, penta, hexa, hepta. 8 is octa. 9 is nona. Whoa. And 10 is deca. I'm sure that's in your book too. But so we count to 10 in Greek, and then the only thing we have to do is add the suffix IDE to the end of the last element, kind of like we did when we were naming anions. So for example, this one I would say mono sulfur, monosulfur, not oxygen, but oxide. Okay. And if you just call it monosulfur dioxide, I don't know why, sometimes they drop off the mono. So some people just call it sulfur dioxide. But I don't care. I just leave the mono ends, you don't have to memorize anything. Monosulfur dioxide. Okay. How about P4O5, Giselle? 4 phosphoruses and 5 oxygens. How would you name that? Tetra phosphorus. Wait, I gotta spell phosphorus. Phosphorus. Okay.
And
Penta. Oh, not oxygen though. Oxide. Okay. So remember, spelling's a big deal. For some reason, some folks, and this is okay, some folks don't like to have the A and the O there. So they say tetraphosphorus pentoxide. So if you left the A out, I'm not going to get on your case. Some people like to write, you can leave it in or out. So they put parentheses around it. Fine, doesn't really matter. But tetraphosphorus pentaoxide. How about water? Audrey, the technical jargon for water. How would you call that? Where's Audrey? Audrey, there she is. Audrey. Dihydrogen oxide, or monoxide. Right? Dihydrogen oxide or dihydrogen monoxide. Either one is very acceptable. Okay? So if you do not see a metal, count to 10 in Greek. Right? Add IDE to the end. If you do see a metal, you have to figure out what the cation is and name it. Figure out what the anion is and name it. Okay, so look for a metal. So here it is. Look at all this stuff. All right? You want to earn the big bucks? Life isn't easy. Know the names and symbols of elements in the first 4 periods of the periodic table. Know the names and formulas of all polyatomic ions. So that charge is a big deal, because remember, the charge becomes a subscript on when you make the compounds. So you got to know the names and formulas, those charges. Know how to name ionic compounds. Look for a metal. Name the cation, and then the anion. Know how to name molecular compounds. You know it's molecular and when you don't see a metal. Naming will be on every quiz up to the first exam. Okay. So what I think would be the best is we just go to the boards, and I've got a bunch of these, right? So we'll do 5 at a time. So write your answer to the first 5, see if they agree with the folks around you, and then we'll erase and go on to the next 5. Okay? Let's give it a shot. So write your answer to the first 5. And we're naming them.
What is Ni?
Ni is nickel.
Okay.
Nitrogen just N. Yep. Okay. Remember, spelling counts. Go through all that work. You don't want to misspell it. It's right. You got it. Po though. Po.
Oh. Hold.
Yep. Oh, and it has 2 S's. Potassium has 2 S's. Yes, it's the same. There's no difference because it's in group 1 or 2.
It's in group 1.
Yeah, group 1 and 2 have exactly the same name. Because their charge has no choice.
Okay, so it's just going to be...
Yeah, it's exactly the same. Don't mess with it.
Okay.
Yep. Okay. So make sure that you and the folks around you have the same answers. Yes, iodide. Iodide. Oh, that's the, but it's DE. Yeah. IDE. IDE is the ending. Okay, so did you get these? So you hopefully you named potassium, potassium, calcium, calcium, and iodide. Good. Iodide. Try the next 5. Or just finish this, yeah, next 5. Finish the box. Yeah, now, yes. Now it's not in group 1 or 2, so now you have to give the charge in parentheses. And it has to be Roman numerals. Yeah, there you go. Good. And they like the...
Oh, you...
Yeah. Yeah, make sure that you give the... when you're doing the Roman numerals, make sure you do it in proper notation. So otherwise, that's 11. So Roman numerals, copper 2. Good. Oh, this is nickel. Nickel. And don't forget your R. And then for these guys, they like to have this.
So,
Yep.
whenever 17, would you have to like...
But we'll get there. We'll get there.
Okay.
Don't forget, these have to be like that.
Oh, like that.
Yeah. Yeah, they're going to be picky. Okay. Okay, did you get the next? So hopefully you wrote nickel 2. Now, I don't know if you caught this. This is a tough one. Whenever an ion does not have a choice, they don't want you to write the charge in parentheses. Aluminum and zinc are the only 2 that are like this. Aluminum is always +3, zinc is always +2. You're technically correct. You should have, following the rules, we should have a parentheses with the Roman numeral 3, parentheses with Roman numeral 2. But aluminum and zinc can only have +3 and +2. Therefore, they follow the same rules as group A. So you just call it aluminum and zinc. Okay? Just call it aluminum and zinc. So try the next 5.
Another question.
Yep.
What if there's nothing, like there's no like polyatomic ion written for the CaOH? Like, you just make
No, that's the entire compound you have to name now.
okay.
They're changing gears
So
now.
you just have to write like what it would be.
Name this cation and then name that anion.
Okay. Does the 2 go to both of these?
No, you're jumping ahead. We'll get there. We'll get there. You'll figure it out, though. Remember, the charges become the subscripts. That's where the 2's coming from. Now, does this guy need his parentheses with the charge?
He just has +4.
Yeah, so that means he has to have the parentheses with the, because is this in group A? He's not in group A. So that means you have to give the, right? And he's not aluminum or zinc. Okay. Is this guy in group A? Right? He's not, so that means you have to, there you go. And he's not aluminum or zinc either.
It's just aluminum.
It's aluminum zinc are the only exceptions.
Only one.
The only, well, yeah. That you're going to have to worry about. Yep.
Just wanted to check this. Would this be it then?
You got it.
Okay.
All right. Let's make sure you're on the right track here. I think I see everybody's answer right. Right? Silver is not in group A, so you have to give the charge in parentheses, Roman numeral. And it's not aluminum or zinc. Good. I think everyone's got it. So then sulfide, I think you wrote S-2. Oxide, O-2. And carbonate, you just got to know it. Try, if you don't know them, just look at the table and cheat for now. The polyatomic table. Oh, not that. Right? What do we call this? Our polyatomic ion chart. So you might just have to look at that if you don't have it memorized. There's no way you just started. You're going to have to use this for now. Okay, let's keep going here. The next 5. What? The next 5. 15 through 20. 15 through 20. Now, when you start with 16, you're naming the entire compounds now. Because notice there's no charges, so you want to look and see if it's molecular or ionic too, and be careful, because they could be thrown in there. Oh, it has a charge though.
Yeah,
So
that's why I said
wait,
no.
you need to. Oh, you don't have your cheat sheet. This thing. It's in this chart of polyatomic ions because it has a charge. That SO4 has a -2 charge, so it's got to be in this chart. There it is, sulfate. All right. Notice that this number 15 has a charge, so he's in that table of polyatomic ions. That's one of those that you just have to know. So if you don't know it, look, find him in the chart. That number 15. Because this guy, he has a charge on him. So that means, oh shoot, I have to know what this is. It's sulfate. It's in that polyatomic ion chart.
How many of these numbers? Oh, okay.
It goes on and on. We'll never get through it all. It's just good practice.
Good.
Okay.
Is it calcium dihydrogen?
Okay. Oh, good question. Okay. Now, do you see a metal?
No. Yes. No. No. Yes.
Calcium. So there's a metal. So should you even think about monodi-tri?
No.
No. So you have to figure out what this ion is and name it. Figure out what this ion is and name it. Okay? And what you can do to help yourself out, you can, if you don't recognize it, remember this guy really goes up here, and that one really goes over here. That might help you. Okay? Right? Because the subscripts are really the charges. And it's always the cation first and the anion second. Hydroxide, it's in the table, exactly. So you call it Ca+2 is just calcium, and OH negative is hydroxide. No monodi-tri stuff because you see a metal. So that's the game you're playing. So if you don't know, you know this has to be an anion, phosphate. If you're not sure what it is, I'd have that chart. See, like Tanya's doing here. I'd have that chart.
Sir, like,
Otherwise, because if you don't have it memorized yet. So grab the chart if you don't have it, because you're going to need it. The polyatomic ion chart. Because if you don't have them memorized, you're going to need it. Okay. Yeah, but don't forget to put this guy's charge up there. Well, we'll put his charge up there. Calcium is what?
2.
Yeah. Okay. And I like. No. All we do is make charges subscripts. That's all we do. But put parentheses around this polyatomics, and then it's easier. Okay. Now make the charges be the subscripts. No negatives, just the number. I want 3 calciums. And you can erase them if you want. But see how this 3 times positive 2 is positive 6. 2 times negative 3 is negative 6. So it cancels out. So it works. Okay. Did you figure out? Find the chart, phosphate. I don't know. You can't do this unless you find phosphate and you know that it's PO4 negative 3. Okay? So, and calcium has to be Ca plus 2. So what you do is just put them together, calcium and the phosphate. And I always put parentheses around that polyatomic, whether I need to or not. It just looks cleaner. Do that. And then I make the charges the subscripts. So move the 3 down under the calcium, the 2 under the phosphate. And I'm done. Okay. And notice how the math worked out. 3 times positive 2 is a positive 6 from the calcium. 2 times negative 3 is a negative 6 for the phosphate. So it adds up to be 0. Okay.
You don't do anything with
No, the 4 is, that's what it's needed there to make that negative 3 compound. Okay. And this guy should be a PO4 parentheses with it. Yeah, so you have to have this whole thing in there. There you go. Yep.
It's a negative 3 up here. Is it supposed to be a negative 3 down here?
No, because this is just the number of them.
Oh, okay, so the negatives don't.
Yeah, you don't transpose, you don't bring the charge down with it. They just want the magnitude, the number of them.
Okay.
Because then 3 times positive, so that number 3 times, then you get a positive 6 and a negative 6. So no signs down here. You just bring the number down.
Okay.
Good. Very good. Potassium carbonate, right? Okay. So did you get the rest of these? Hopefully you said sodium nitrate. And you said K2CO3. And you can have a 1 down here if you want, right? But a lot of folks just kind of ignore the 1. And copper 2 sulfate. Now here's kind of a trick question. I wonder if anyone caught it. Copper is a plus 2. Sulfate is a negative 2. So you want to move these down here, right? And make it 2 2s? You want to make this a 2 and that a 2? Right? Does everybody agree? Right? Copper 2 sulfate. This is what it should be so far. However, all ionic compounds are crystals. All molecular compounds are all molecules flying around. So what a crystal is just a ratio. So they always want the simplest ratio for crystals. So all ionic compounds, there's always one last step. And that is, can I simplify this ratio? And you can. You can make it 1 to 1. So you have to erase the 2's. So the answer for copper 2 sulfate is this, CuSO4. Do you want to? Stephen got it, right? Okay. So let's do one last one, and then we'll call it a day. Let's name this one, 29. Name 29, and then we'll call it a day. You guys can have a great weekend. Go get free pizza at 12:30. Let's name 29, and then we'll call it quits. Yeah, look for a metal. There's no metal there. So good. Everybody's counting to 10 in Greek. We'll find out.
It's not a, is it?
Keep going. Disulfur. This is right. This is a U, though. Keep going.
E?
No, U. Disulfur. Did you guys get it? Disulfur. Dichloride. You got it. Disulfur dichloride. Have a good weekend.